We have a source that starts from here, and here we have a stationary observer also. So at t is equal to 0, this source starts from here and moves towards right with an acceleration AC. We need to find what is the oscillation frequency registered by the observer 10 seconds after the start of the motion. So let's say after 10 seconds, the frequency received by this observer was emitted by the source at this point. So again, we need to find the frequency registered at t is equal to 10 seconds. So at t is equal to 10 seconds, whatever frequency is registered here, that is omitted at some time here when the particle is at this point. So the time it takes for this source to move from here to here, plus the time it takes for sound to travel back, that is the total time, 10 seconds. Now acceleration is uniform, so we can calculate t1. Okay, before that, let's just read what we just discussed. Let's say sound pulse emitted by source at point P is the one that reaches O in given time t second. So in the total time t second. And velocity of the source at P be Vs. So here t1 is the time taken by source to reach P, and t2 is time taken by sound that is emitted at P to reach observer. So total time t, that is 10 seconds, is equal to t1 plus t2. Now we are assuming the velocity here to be Vs. So t1 is Vs by AC because the source started at 0 velocity. Acceleration is AC. So you can use V is equal to U plus AT to get t is equal to Vs by AC. Also this distance covered, so that again you can use the equation of motion. So V square is equal to U square plus 2S gives the distance to be Vs square by 2AC. So this distance is covered by the sound. So T1 is Vs by AC and T2 is this distance upon velocity of sound. So Vs square by 2AC into V. So we simplify that and we get Vs to be this. So the frequency emitted at this point, which is received by O, will be F0 into V upon V plus Vs. So if we put the value of Vs here and simplify, we are going to get our answer. All right.